This is Michael Polkabla from Biomax Environmental on behalf of NAML.
Okay, thank you. And I'm going to be following up with some parallel discussions relative to what Peter just presented as well, too. A couple of my slides are the same, but I'm looking at them from a different perspective. But let me just start by saying that it's really a privilege and an honor to be amongst, this group. All right, people who care, people in the community, scientists who are donating their time, who are, asking for grants to do this and to fund this very important issue and to get information such that we can move forward and this doesn't happen again. Ultimately, that's our goal, right? We want to learn from this incident, study it, see what the implications were from this incident, and then make some effective changes so that this doesn't happen elsewhere. This is me. Basically, we're going to cover what a volunteer group did and found and why we went looking. Well, I'm a certified industrial hygienist. I'm the owner of Biomax Environmental, and my job is to basically measure and evaluate what people are exposed to. This is a picture that I took from my car when I saw the news reports. I immediately got in my car, and I was in Pacific Grove. I went down to the beach, and I was like, "Holy shit!" Okay, lithium battery fire. All right, and I turned on the news, and there's Dan Green with Felix, and Glenn Church. Who were, being interviewed right in front of the Vista site. And I immediately said, "Oh my God, I know about lithium battery fires, hydrogen fluoride. All right, let's just start with that. That stuff will kill you right now." And they were so close that, I got on the phone. I know Dan. And so I got on the phone with him and he was giving the 5 o'clock news. And I said, "You got to get Felix out of there." I go, "He's wearing a dust mask. That's not going to help you with hydrogen fluoride." Right. So originally and then I'm starting to wonder, well, EPA and the county's got to be involved, right? And then I realized by seeing what was being discussed on the news that I knew more about what was going on from my biochemistry background than the local people knew. Certainly more than the firefighters who were setting up a perimeter who were evacuated. Right. Evacuation is not a mitigating factor there. That is, they set up a perimeter. Let it burn, right? But on January 16th, we know that the plant caught fire. And I went and looked at it from across the way and look at that plume in the picture. It's going up and then it's dispersing. Okay. And so on that day and that evening that followed, we were asking the very common question, what's the smoke plume made of and how is it dangerous? Because that's one thing that was not being answered. On the news, they had quoted me because Dan asked, he says, "Well, we don't know what this is. How do we know if you're being exposed to too much?" And I said, "Well, we don't know currently." And I said, my answer was that to tell your viewership, if you can smell the smoke, you're too close. If you can smell it, you're being exposed to something. That's common industrial hygiene sense, right? And if you don't know what it is, that could be something that's hurting you. All right. So that's sort of tying this all together. It's just some facts we know about this. January 16th. Lithium battery storage facility caught fire, largest of any kind in the world. It burned for days. Weeks later, though, we had a reignition, right? On February 18th. And we did some follow-up monitoring based on that as well, too. And so that's important. But one thing to put in perspective, how big is this thing? Well, it was a 300 megawatt facility, but 30 megawatts were being basically burned. That's what burned out of that 300 megawatt facility. That's equivalent to about 16,000 Tesla Model 3s burning. And if you guys have been on YouTube and seen Teslas burn, they're pretty spectacular. And that's one Tesla. This is 16,000 of them. So the air was being checked, but what was being carried in the smoke plume and what landed on the ground? That was the big question. So during the fire, the official EPA county monitors measured and reported the air of no acute exceedances of health limits. Don't get me started, because no acute exceedance of health limits does not mean it's safe. That just means there's, what health limits are we talking about? And we'll see about PM 2.5. That doesn't capture the full picture. PM 2.5 is everything, right? We're just looking about the actual metal chemicals, which have their own toxicities. Targeted air monitoring doesn't capture what settles on the roofs and cars and patios, surfaces that people actually touch, and no one was measuring. So we organized to do just that. I got on Facebook too, because I was just like watching the news and just going, wow, this is incredible. And I saw my Facebook blowing up, and on there was this guy, Brian Roeder, who's sitting in the room, and he's talking about asking questions. And I literally chimed in on social media saying, well, I know what's in this thing, hydrogen fluoride, let's start with that, but what concerns me is what's in that plume, where's that plume going, and where's that ending up, right? From all this other data. And so that was a question that was not being answered by or addressed by the local health authority. So Brian got together with his wife and, we organized over 100 community volunteers. We were trained to collect surface samples over a single weekend. Each person was provided with a sampling kit. It's underneath my chair over there. I failed to bring it up to show you, but it's just a Ziploc with gloves, a template, ghost wipe samples in a container. We collected 124 samples in 9 to 10 days after the fire, very importantly, before it started to rain. And we had a certified analytical lab we measured the battery indicator metals, nickel, manganese, cobalt, and lithium. ALS Analytical was the company who did it, and they gave us a huge discount. And Brian actually funded this. So with his own dollars, he said, Michael, I'm gonna fund this. Let's see what we can do let's get the samples, and we'll deal with the cost later. And this is where these are the sampling sites that we gathered for all the data that we sampled. This is significant. 121 surface samples were collected, including 3 field method control blanks. And we sampled over 47 miles difference between up into the San Jose Valley, all the way down to Pacific Grove and Carmel, covering 3 counties. And those dots represent areas where the samples were collected. So 121 active samples and 3 field method control blanks. This is some information that shows the plume on the 3 different metals, the nickel, manganese, cobalt, and lithium. As you'll see, those are the 3 highest levels, those are the 8 highest levels of the results, all well within the plume itself. And that's a high split data of, but it's over the 2 days of the sampling, that's what the model showed. So all the most elevated samples were within those areas. And this is what the data shows. Okay, what we have on the y-axis here is the micrograms and micrograms per 100 square centimeters using the template and distance from the site. What you'll see is a peak right at about 4 miles and then going out. That's consistent with a plume deposition because the plume was going straight up and then it was dispersing, and then these particles have mass and density. They start settling. So this is consistent with scatter plotting and also with plume deposition. It also matches what Dr. Aiello's and these other scientists' findings have been, which is the signature, the battery signature, which is the nickel, manganese, cobalt, the 5-3-2 ratio. As you'll see in the first, right here, this is the battery recipe. As far as we can tell, we don't have confirmation of the exact recipe for the district fire, but this is the recipe of a 5-3-2 near the fire. It showed very, very consistently close to that. And as we get away, it goes back down to the background. And yes, it was independently confirmed by Dr. Aiello's work. You saw this data before in the recent slide. But what's so important here is that this is a timeline. This is the 11, 13, 15, 17, PM 2.5. PM 2.5 is any type of particle that's airborne that's less than 2.5 microns in size. It's pretty consistent. And then as soon as the fire occurs, we have spikes. This is the Aroma School. We have a Hollister School as well too. And the other locations show a similar type of dispersion. What's important here is to remember that it's not just particles of dust and agricultural dust. These are particles of nickel, manganese, cobalt, lithium. All right. So it's not just wood fire. It's not so char and ash. This is a chemical fire. So the composition is different. And that's why people are having health effects. Now, the big elephant in the room is that, okay, so we've established that the levels were higher. We've established that it meets the signature. How do we interpret the data? Ed was just asking me during lunch. He's like, all right, is it going to hurt me or not? That's a very difficult question to answer. And so what we can do, we can look at regulatory modeling and toxicological modeling in order to answer that question, but it's going to give you a range. And I just provided 4 of them right here. Kleinerman Associates, who does lab closures and so forth, he's an expert in this field. We came up with these numbers as well, for lithium, cobalt, manganese, and nickel. The Brookhaven National Laboratories, the SOP, it's an industrial hygiene model. It comes up with some different numbers. Then there's an EPA, RSL level. There's a child exposure model. Bottom line is, it's showing that there's a range of what's considered to be acceptable versus not acceptable. And it depends on who you ask, right? But let's now get back to the next question. Even if we pick one of those models, I picked one here for this representation, this graphic, and that is the Kleinerman Associates models, which we used in some of our original data that we put out through NAML. How many of those data points exceeded the benchmark standard, what we would say is acceptable or not? And there's the answers. All of them above this baseline level here, those were above that benchmark standard. And there's a similar graph for these other models as well too. So there you have it. There's 27 out of 100 and out of 100 and so for nickel, manganese, cobalt, lithium. We have exceedances. And what's important is that the peak deposition was at about 4 miles from the source, which is still consistent with plume, dispersion, settling type modeling. I'm sure that Dr. Smith is going to talk a little bit about the health-based issues, but let's not forget, okay, if you're being exposed to something, how could it hurt you? Well, in nickel, it's a recognized human carcinogen. It's a sensitizing agent. People have nickel allergies, like when there's too much nickel in a ring, for instance. That's a problem. Manganese, needed in the body in tiny amounts, but harmful to the nervous system. Cobalt, it can trigger asthma and lung problems. And lithium, least studied, and then sometimes that's why it's not in here. It's most useful here as a marker in the material that came from the batteries. So what does the data tell us? The fire left 4 battery metals, nickel, manganese, cobalt, and lithium, and it matched the signature, and it aligns with the battery fingerprint. The levels were the highest near the fire and generally fell off with the distance. The metals carry recognized health concerns, which is going to be talked about by Dr. Smith in a little bit. And the trained community volunteers, we captured the signal early. We verified it, and we were able to do it faster than the regulatory authorities could do it. So nice job. Importantly, what can we take forward? Sample the surfaces early. Wipe sampling can be performed, but it has to be done quickly, okay? Because of this natural attenuation occurs. Know the baseline before if we can. I'm hearing a very solid similarity here between all of us asking the same question. Wouldn't it be great if we had baseline data? Dr. Aiello had it. We don't. So maybe that's something that we build into the planning and permitting section. Well, we require that for the future. But community science works. We mobilized and trained neighbors and we gathered solid scientific data quickly. We trained you guys. I had a YouTube video that I put together on my kitchen table, and you guys just nailed it. We all were very standardized. It's defensible. Let's make sure we keep asking the questions. The questions are, what about farmland? What about indoor dust that got inside your house? And the longer term exposures, what are those? So with that, I know I'm running out of time. Happy to answer questions, but I just want to applaud that group. It was such an incredible group that came together. The NAML, Brian Roeder, Tony, Ed, you guys are outstanding. Dr. Aiello and all the colleagues in here, I've learned a lot today, and it's painting the picture of which is similar, that we're seeing similar data. We're seeing these markers across all the board, across the water, across the invertebrates, the mussels, the muds, and so forth, all showing the same thing. And ALS Laboratories, who gave us a huge discount on the analysis for this, and Brian for funding that bill. Thank you, Brian. And for the 100+ volunteer community members. Way to go. Happy to take questions. Yes.
A really quick correction on your number of Tesla cars. I think the 16,000 Tesla car number is for the entire campus. Whereas the Moss 300 would be more like 4,000 Tesla cars, which is still a ton, like a bunch.
Thanks, I'll look into that. I'd had the calculation and I'll make sure I correct that. Thank you.
Cars.
Still a lot of cars, yeah.
Do we have questions on Zoom?
Yes, we do. Can you give examples of health effects?
Well, I did have the one slide on some of the health effects, which right here, for some of these metals, but I believe Dr. Smith is gonna go into further detail on that. Is that true? Later today?
Yes.
Okay, so yes, I don't want to steal the thunder. So, yeah, just in general, carcinogen, nervous system issues, central nervous system issues, asthma for cobalt, lithium, least studied, but more of like marker. Yes.
And I'll do one more then. So this question was asking about the negative results and what those mean. I know maybe might have been one of your first slides.
Well, negative results are not necessarily a bad thing. It just shows that, and that's why by collecting so many samples, that's out into a curve, into a plot. Negative results could have been where that sampler decided where to collect the sample from. Okay, and on certain surfaces, there were lower numbers. Other surfaces, there were higher numbers. Because these were wipe samples within a 100 square centimeter template. And that's gonna just be inherent variability.
The other thing possibly that question referred to is the one slide where you standardized to 0 for your threshold, and so the points were either above 0 or below 0, and that's because you had standardized that one.
That one. Oh, that one. This is the 0 is the actual, this is the threshold set by the Kleinerman Associates benchmarks, which were here on the left, on the second column to the left, the 20, 80, 100, 140. That's the 0 level that was set. So that is a benchmark standard that says if you exceed it above 0, it's exceeding the standard. If it's less than the 0, it was acceptable according to that particular standard set. That's a good question. Yes.
This slide, it says the EPA for lithium is 50 and Kleinerman is 20. That's
Yeah.
double. So from a human response, like if you're looking at lithium, do you know the health difference between an exposure at 20 and 50?
It depends on the models that they're utilizing in order to make that calculation. And the details of that I could go into you with, but these are things like the exposure assumption that the 100 square centimeter template is the size of a human palm.
Okay.
Okay, and it also goes to, if it's based on water-based standards, the toxicological standard is a normal human drinks 2 liters of water per day. If you're comparing it to a water-based acceptable limit. So it depends on which standards they're pulling from. Some of them are airborne hazards, some of them are water hazards, some of them are ingestion hazards.
We can take one more question.
And just in regards to the question regarding health impacts, you can go to neveragainmosslanding.org to our website, and on the homepage, there is a diagram that you can click on. It shows self-reported health symptoms that occurred in over 1,000 people in the weeks following the fire. And while they're anecdotal in nature, and they may be unrelated to the fire, it's still a very compelling list that people can check out to see what was reported in the way of health impacts, assuming it came from the fire.
Yes. Thank you.
Thank you.